When reusing existing conductors and a new conduit for feeding another panel or equipment, you must adhere to the requirements outlined in NEC section 300.16b. Firstly, the conductors must be marked or identified as part of the original system. This ensures that the electrical system's integrity is maintained and that future modifications or maintenance can be performed safely and efficiently. Secondly, the conductors must be free from damage, deterioration, or other defects that could affect their performance. Conductors with compromised insulation or physical damage can pose significant safety hazards and should not be reused. Thirdly, the conductors must be securely protected from physical damage and from contact with other conductors or grounded objects. Proper protection minimizes the risk of short circuits, ground faults, and electrical shocks. Fourthly, the insulation of the conductors must meet the requirements of the applicable NEC article for the new use, considering the voltage, temperature, and other environmental factors. The insulation must be rated appropriately for the operating conditions to prevent insulation breakdown and electrical hazards. Fifthly, the conductors must be accessible for future maintenance or replacement. Accessibility ensures that any necessary repairs or replacements can be made without undue difficulty or disruption. In addition to these specific requirements, there are several additional considerations. The new conduit must be the appropriate size for the conductors and must meet the requirements of the NEC article for the new use. Using the correct conduit size prevents overcrowding of conductors, which can lead to overheating and insulation damage. The conductors must be pulled through the new conduit using the proper techniques to prevent damage. Avoid sharp bends or excessive pulling force, as these can damage the conductors or their insulation. The connections at the panel or equipment must be made correctly and in accordance with the manufacturer's instructions. Proper connections ensure secure and reliable electrical connection. The system must be tested and inspected to ensure that it meets all applicable NEC requirements. Testing and inspection verify that the installation is safe and compliant with the electrical code. Regarding conductor identification, you must clearly mark each conductor to indicate its function within the electrical system. This is typically achieved through color coding or labeling. For example, the NEC specifies color codes for different types of conductors, such as black for ungrounded conductors, white for grounded conductors, and green for equipment grounding conductors. When inspecting conductors for damage, pay close attention to the insulation. Look for signs of cracking, brittleness, or abrasion. Check for any physical damage to the conductor itself, such as cuts, nicks, or kinks. If any damage is found, the conductor should not be reused. When protecting conductors from physical damage, use appropriate conduit and fittings. Ensure that the conduit is properly supported and secured to prevent movement or vibration. Protect conductors from exposure to moisture, chemicals, or other environmental factors that could cause damage. When selecting conductors for reuse, consider their ampacity. The ampacity of a conductor is its current carrying capacity, which is determined by its size, insulation type, and operating temperature. Ensure that the conductors have sufficient ampacity for the intended load. The NEC provides ampacity tables that can be used to determine the appropriate conductor size for a given application. When making connections at the panel or equipment, use appropriate connectors and terminals. Ensure that the connections are tight and secure to prevent overheating and voltage drop. Follow the manufacturer's instructions for making connections. Before energizing the new circuit, test the insulation resistance of the conductors. This test verifies that the insulation is intact and that there are no ground faults. Use a megometer to measure the insulation resistance. The NEC specifies minimum insulation resistance values for different types of conductors. After completing the installation, inspect the entire system to ensure that it meets all applicable NEC requirements. Check the conduit installation, conductor connections, and equipment grounding. Verify that all components are properly labeled and identified. It is recommended that a qualified electrical inspector perform a final inspection of the installation. When dealing with electrical systems, always prioritize safety. Wear appropriate personal protective equipment such as gloves and safety glasses. To energize the circuit before working on it, If you are not comfortable working with electricity, hire a qualified electrician. The NEC is a comprehensive set of electrical safety standards that is updated regularly. It is important to stay up to date on the latest changes to the NEC. Consult the NEC for specific requirements related to your application. Local jurisdictions may have additional electrical codes and regulations that must be followed. Always comply with all applicable codes and regulations. The NEC provides detailed requirements for the installation of electrical systems in various types of buildings and occupancies. These requirements are designed to ensure the safety of people and property. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is essential for electricians, engineers, and other electrical professionals to have a thorough understanding of the NEC. The NEC is a complex document, but it is well organized and easy to navigate. The NEC is divided into chapters, articles, and sections. Each section contains specific requirements related to a particular topic. The NEC also includes numerous tables and figures that provide additional information and guidance. When using the NEC, it is important to understand the definitions of the terms used in the code. The NEC includes a glossary of terms that provides definitions of common electrical terms. The NEC also includes annexes that provide additional information and guidance. These annexes are not part of the enforceable requirements of the code, but they can be helpful in understanding and applying the code. The NEC is a living document that is constantly being updated to reflect changes in technology and industry practices. The NEC is typically updated every 3 years. It is important to use the latest edition of the NEC to ensure that your electrical installations are safe and compliant. Many resources are available to help you learn about the NEC. These resources include training courses, seminars, and online resources. The National Fire Protection Association, or NFPA, which publishes the NEC, also offers a variety of resources to help you understand and apply the code. Understanding the NEC is essential for anyone working with electrical systems. By following the requirements of the NEC, you can help ensure the safety of people and property. Remember that electrical work can be dangerous, and it is important to take all necessary precautions. If you are not comfortable working with electricity, hire a qualified electrician. Furthermore, conductor identification is crucial for maintaining the safety and integrity of electrical systems. Proper identification allows technicians to quickly and accurately identify conductors during maintenance, troubleshooting, or modifications. This reduces the risk of accidental contact with live conductors and ensures that the correct conductors are used for specific purposes. When conductors are not properly identified, it can lead to confusion and errors, which can have serious consequences. For example, if a technician mistakenly disconnects or connects the wrong conductor, it could result in a short-circuit, equipment damage, or even electrical shock. Therefore, it is essential to follow the NEC requirements for conductor identification and to use appropriate methods to ensure that conductors are clearly and accurately marked. In addition to color coding, other methods of conductor identification include labeling, tagging, and marking with alphanumeric characters. The specific method used will depend on the application and the requirements of the NEC. Regardless of the method used, it is important to ensure that the identification is durable and easy to read. The identification should be resistant to fading, abrasion, and other environmental factors that could degrade its legibility. Furthermore, conductor inspection is a critical step in ensuring the safety and reliability of electrical systems. By inspecting conductors for damage, deterioration, or other defects, technicians can identify potential problems before they lead to failures or safety hazards. During an inspection, technicians should look for signs of physical damage, such as cuts, abrasions, or cracks in the insulation. They should also check for signs of overheating, such as discoloration or melting of the insulation. In addition, technicians should inspect the conductor connections to ensure that they are tight and secure. Loose connections can cause overheating and voltage drop, which can damage equipment and create safety hazards. If any damage or defects are found during an inspection, the conductors should be repaired or replaced immediately. Ignoring these problems can lead to more serious issues down the road, including equipment failure, electrical fires, and electrical shock. Conductor protection is another important aspect of electrical safety. Conductors must be protected from physical damage, moisture, chemicals, and other environmental factors that could degrade their performance. This protection is typically provided by conduit, raceways, or other enclosures. The type of protection used will depend on the application and the environment in which the conductors are installed. For example, conductors installed in wet or corrosive environments may require special types of conduit or enclosures that are designed to withstand these conditions. In addition to physical protection, conductors must also be protected from overcurrents. Overcurrents can occur when there is a short circuit, ground fault, or overload in the electrical system. These overcurrents can cause conductors to overheat and potentially start a fire. To protect conductors from overcurrents, the NEC requires that they be protected by overcurrent devices such as circuit breakers or fuses. These devices are designed to interrupt the flow of current when it exceeds a predetermined level. The size of the overcurrent device must be appropriate for the ampacity of the conductor. The ampacity of a conductor is its current carrying capacity, which is determined by its size, insulation type, and operating temperature. The NEC provides ampacity tables that can be used to determine the appropriate conductor size and overcurrent protection for a given application. Ensuring conductor accessibility is also essential for future maintenance and repairs. Conductors should be installed in a manner that allows them to be easily accessed for inspection, testing, and replacement. This typically means installing conductors in conduit or raceways that can be easily opened or removed. In addition, conductors should be labeled or tagged to indicate their function and destination. This will help technicians quickly identify the correct conductors during maintenance or troubleshooting. When conductors are not easily accessible, it can make maintenance and repairs more difficult and time-consuming. It can also increase the risk of accidental contact with live conductors. Therefore, it is important to follow the NEC requirements for conductor accessibility and to ensure that conductors are installed in a manner that allows them to be easily accessed for future maintenance and repairs. Understanding these aspects of reusing existing conductors in new conduit, including conductor identification, inspection, protection, ampacity, and accessibility, is crucial for ensuring the safety and reliability of electrical systems. By following the NEC requirements and best practices, technicians can minimize the risk of electrical hazards and ensure that electrical systems are installed and maintained in a safe and efficient manner. Remember to consult the latest edition of the NEC and local electrical codes for specific requirements and regulations.